Okay, we're learning something in this segment called completing the square. All right, we're going to use algebra tiles. So before I introduce the algebra tiles, there is a prerequisite skill that I need you to understand how to represent 3 times 4 using the rectangle model. Okay, you might think of 3 times 4 as 4 plus 4 plus 4, right? If we use the rectangle model, what that means is that we literally go 3 across this way, right? Here's 3 squares, and then 4 across this way, right? To show that there are a total of 12 squares. So this would be a rectangle. If I showed 4 by 4, right? There's a reason why these are called perfect squares, right? That's because I have 4 this way, and it literally makes a square. Okay, so when we do this operation called completing the square, we are going to literally make a square. Okay, let me introduce algebra tiles. This length here is X. Okay, red stands for negative. Red is the universal color for debt. So if I say a business is in the red, then the business is losing money. So all of these algebra tiles have 2 sides, a blue side for positive, a red side for negative. Okay, then we also have units of 1. Okay, so this represents X, some unknown value. This represents 1 unit. Okay, that's -1. This is +1 when I flip it over. And so clearly this square here, right, represents X squared. It has a length and a width of X, right? So this represents X squared. So if I go to complete the square for a problem such as this, X squared plus 10X. Okay, and I want to do this thing called complete the square. I want to make a square out of that. So if I laid out here, X squared, there's my X squared, plus 10X, they're positive, so I want them on the green side, right? So I've got to get all 10 of them here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then what I do to make a square is I take half of these and I put them down here. Okay? So what I can see that I have now is X, and then 5 units on this side, and then here I have X, and then 5 units. Well, what do I need to complete this entire square, right? The entire thing is a square. So I have to come here and fill in with units. I'm not going to take the time to do it because I don't feel like counting them all out, but I could fit in this section, it would take me 25 little units to fill in to make this a perfect square. So this would be 25 units. Now, I have been stressing lately that I can't, I have to change the appearance, but not the value. So I can't just say, oh, well, I just feel like adding 25. That would change the value. So the 3 things that I can do, one of them is add 0, multiply by 1, substitute anything for its equal. So what I'm actually going to do here then is I'm going to say, okay, I want to add 25, but it's not legal to add 25. I can add 0, right? So look at what I've done. I've taken this expression, I've written it as X squared plus 10X plus 25 minus 25. But then I can take just this section and write it as X plus 5 squared, right? And then I'd have minus 25. That is equivalent to the original expression, right? This, my original expression, which was just X squared plus 10X, that is equivalent to what I wrote over there. So I've added 0, okay? So let's try another one. Let's try X squared minus 6x. Okay, and I want to make a square. So here's my x squared, it's positive. I need 6 x's, but they are negative, so I have them on the red side. And so I've got all 6 of them here. Now, if I want to make a square, okay, the way that I do that is I take half of these and I put them down here. Okay, then right here I have x and then 3, right, because this would be 3 units. X plus 3. Well, I suppose this is small enough for me to actually fill in the units. I don't have to count up 25 like I did the last time. Don't forget, negative times a negative is a positive. So when I fill in 9 units here to make that perfect square, I have them on the positive side, right? Because a negative 3 times a negative 3, which is what I have, negative 3 by negative 3, gives me positive 3. So in order to complete the square, what I have to do is add 9. Well, I can't just add 9, I have to add 0, right? So I add positive 9 minus 9 so that I change the appearance and not the value. And then I go like this and say, okay, well, what do I have here? I literally have x minus 3 squared, right? Because I have x minus 3 on this side, x minus 3 on this side, so I should put the minus here to show because of the negative. And then that included the 9, so then I have that, which is equivalent to my original expression. Let me push this up a little bit to make sure you can see it. Okay, let's try just a couple more. Let's look what happens. So far I've been working with expressions. Let's look what happens if I have an equation. Uh-oh, do I not have enough blank paper? Here we go. So let's look at, say, x squared plus 8x plus 1 equals 0. Say that I have this equation and I want to complete the square, right? So I'm going to focus on this part. And with the equation, since I'm focusing on this part, how about I write it like that, okay? Now I'm going to complete the square for x squared plus 8x. So I'm going to lay out x squared. That's a positive 8x, so I'm going to lay out all 8 of these. 5, 6, 7. Oh, I'm on the red side. I should be on the green side, right? Because it's a positive 8. All right, so complete the square. I have a rectangle. I want to make a square, so I take half, bring them down here. How many units do I need to fill in? Right, well, I have a 4 by 4 region here, so I would need 16 units for 4 by 4. So I'm not going to bother counting those all out, but 16 would complete the square. So to be legal, now that I have an equation, I'm legal if I do the same thing to both sides. Okay, so I could come to my equation and add 16 here, add 16 here. All right, then I get x squared plus 8x plus 16 equals 15. And then right here, I can write this as, this is x plus 4. This is x plus 4. So I literally have x plus 4 by x plus 4. I have a square equals 15. Okay, so I have completed the square, and we're going to have a whole section later on solving quadratics. One of the ways you could solve the quadratic is right here. You could take the square root of both sides and then subtract 4 from both sides. So that is one of the ways that we learned in high school to solve quadratics. Typically, we don't solve, I mean, at least in Calc 1, I don't emphasize that method of solving quadratics, but I could use that. So thanks for watching, and I hope you found the manipulatives to be helpful.